Hello everyone. In the previous series of lectures, we have seen about the concepts related to strain energy and the strain energy stored due to gradually applied loading, impact loading, suddenly applied loading, as well as the strain energy due to shear and bending. We'll move on to the lecture 4. In lecture 4, we are going to deal with the problems related to strain energy. Let us look into the problem 1. An axial pull of 50 kN is suddenly applied to a steel bar 2 meter long and 1000 mm square in cross section. If the modulus of elasticity of the steel is 200 kN per mm square, find the maximum instantaneous stress, maximum instantaneous extension, strain energy and modulus of resilience. Before going to the solution, have a look into the problem and identify what type of load is given. Here it is given as suddenly applied loading and the value of the load is given as 50 kilonewton. Area is given as 1000 mm square. Length is given as 2 meter. Before proceeding with the problem, see to that you have all the units all in the same units, that is 1 in meter, 1 in mm. You just convert it into your comfortable units. E is given as 200 kilonewton per mm square. So area is given in mm square, length is in meter, convert it into mm. So it will be 2000 mm and Young's modulus is given as 200 kilonewton per mm square, convert it into Newton per mm square. So it will be 10 power 3 Newton per mm square. Have a look into the problem again. What are asked to find out? First, you are asked to find out instantaneous stress. What is the condition given there? The load is suddenly applied. What is the formula for stress for suddenly applied loading? It will be 2 times of the stress due to gradually applied loading, which is 2P by A. All the values are given in the problem. Just substitute everything and find out stress. Next, what is the next question asked? Instantaneous extension. And here Young's modulus is given as stress by strain. So strain will be stress by Young's modulus. So this is the value of stress we have found out in the previous step. The Young's modulus value is already given in the problem. So substitute and find out strain. We are asked to find out the extension, but we have found out the strain. So what is strain? It is change in length by original length. We are asked to find out this delta L, and delta L will be strain into length. Strain value is known, length is given in the problem. Substitute and find out delta L. Next question is, we are asked to find out strain energy. Formula for strain energy is sigma square by 2E into V. Sigma is known, E is known. What is V? It is area into length. V is area into length. Area is known, length is known. Substitute and find out strain energy, which is Newton mm, 50,000 Newton mm. Next question is modulus of resilience. What is modulus of resilience? It is proof resilience per unit volume, and this volume will get cancelled because it is per unit volume. Both the volumes will get cancelled, and modulus of resilience will be sigma square by 2E. Substitute the value of sigma and E. This is the formula for modulus of resilience, which is per unit volume. So it is given as per mm cube. Next problem. 1500 mm long wire of 25 mm square cross-sectional area is hung vertically. It receives a sliding collar of 100 Newton weight and a stopper at the bottom end. The collar is allowed to fall on the stopper through a height of 200 mm. Determine the instantaneous stress induced in the wire and the corresponding elongation. Also determine the strain energy stored in the wire. Take the modulus of elasticity as 200 GPa. What is given here? the load is dropped it falls through a height, hence it represents impact loading. Okay, so the load which is given is 100 Newton, area is given as 25 mm square, length is given as 1500 mm, modulus of elasticity is given as 200 GPa. We are asked to find out stress, we are asked to find out elongation, also the strain energy. First one, let us find out the stress due to impact loading. This is the formula for stress due to impact loading. P by A plus root of P square by A square plus 2EPH by AL. Load is known, area is known, Young's modulus is known. Substitute all the values. Length is also given in the problem. Substitute all the values. Find out the stress. The stress what we have got here is 465.89 Newton per mm square. Next, we are asked to find out the elongation. So what is elongation? Delta L. What is delta L, which is P L by A E. We can use this formula, or instead of P by A we can substitute sigma, because we have found out sigma in the previous step. Either way you can go. Here I have used sigma L by E. I have used the value of sigma from the previous step. Substitute and find out the value of delta L, which is 3.49 mm. The third question which is asked in the problem was strain energy which is stored in the wire. Strain energy is sigma square by 2E into V. Sigma value is known. Young's modulus is known. Volume is not directly given. Instead of volume, we can use area into length. Area and length are given in the problem. So we can substitute that and find out the strain energy. Let's move on to the third problem. Here a stepped bar is given, which is made with an elastic material, and this bar is subjected to an axial load of 1 kilonewton as shown in this figure. So it is a stepped bar. This segment is taken as 1, this segment is taken as 2. This is the load, axial load, which is applied in the bar, which is 1 kilonewton. The properties of both the segments are also given here. That is the length of the first segment, area and Young's modulus. Same way, all those values for segment 2 is also given in the problem. We are asked to find out the strain energy stored in this bar. First one, you can find out, or you can write the values which are given for both segment 1 and segment 2 separately. So all these values are taken from the figure which is given in the problem itself. So just write down the given values. Axial force in each segment will be equal to the total force which is acting, which is given as 1 kilonewton. So it is 1000 Newton. What is the formula for strain energy? Formula for strain energy is sigma square by 2E into V. This is the formula for strain energy. But we do not know the value of sigma. Instead of sigma, you can substitute P by A. Here it is sigma square, so it will be P square by A square. When you substitute here, that is in this formula, instead of sigma, if we substitute, it will be P square by A square. Already you have 2E here. Instead of volume, you can write A into L. So here you will have one A, and in the denominator you will have A square. It will get cancelled, one A will get cancelled, and it will be P square L by 2AE. So this formula is derived from this one, sigma square by 2E into V. Strain energy is calculated for each segment separately, and then both the strain energies are added together to find out the total strain energy of the bar. So for segment 1, take it as U1. So it will be P square L1 by 2A1 E1. P is 1000, L1 is given for segment 1 as 400, A1 is given as 100 and E1 is given as 2 into 10 to the power of 5. Substitute the values and find out U1. In the similar manner, find out the strain energy for segment 2. Substitute all the values given for segment 2 and find out the strain energy. What will be the total strain energy? You add both U1 and U2. This will be the total strain energy which is stored in the bar. In the problem, they have asked the total strain energy of the bar. So you have to add the strain energies what you have calculated for both the segments to find out the total strain energy. Here it is 35 Newton mm. Thank you.